Yeah.
New metric.
So this is a bit of a follow-on to the last meetup we had, where I was showing some of the development work I've been doing lately. But as you might remember, and for James's benefit, I actually live in Australia normally, and I've been here since November. And I'm trying to do some development work, and I needed an oscilloscope, and of course I didn't pack that in the luggage with me. So I went out and bought one, and a PC based. I thought, well, for people's benefit, you can actually see what it looks like and how well it works. This is claimed to be I think a 20 meg bandwidth, and it actually doesn't work too bad. The problem I had is I'm just going to change. I'll just change cameras. So I've got a breadboard with an ESP32 running on it, and then I've got a which is giving out a square wave, 0 and 5 volts, or 0 and 3.3. It's frozen. Give me a second. I won't come back to that. So the ESP putting out 0 to 3.3, a bit like a pi, and I needed to swing minus 12 to plus 12. So I've got a voltage comparator, etc. But I couldn't quite see what was going on, so I end up buying this this scope. See if I can restart. What I'm actually doing is I've got my mobile phone working as a second camera. No, it's not going to work. And simply it's a external box plugged into the USB port. So if I share my screen, so this is the oscilloscope running now. And what I'm putting out here is I'm running an interrupt in the ESP, and I want to actually see whether the interrupt was actually working correctly. Well, I had, and here I'm putting out pulse width modulation at 70%. I wanted to see whether it was working fine, and I also wanted to see the output of the comparator to see what the rise time, etc., was. So this. So this scope has got 2 channels. I can turn on the right hand side. I can turn the second one on. If I want to change the time base, I can simply select that. So it's not too bad. The idea of actually pulling this knob around is it's a bit tricky, so I prefer to use the pull down. I can set the voltage, the volts per graduation. That works pretty well. It rescales automatically. I've got the probes running on 10 times, so I can rescale the voltages correctly, and I can move them up and down. Up and down. You can also drag them left and right and sort of line up if I want to use the graduations. So it's not too bad. I'm quite surprised. Change which I trigger off the first channel or the second channel, positive and negative triggering. So all in all, this is not too bad. It actually took me a while to figure out where the settings were in this software. But what's actually quite good is the ability to hear. I'm actually got on channel 1. I'm showing frequency. So down the bottom here you can see it's a kilohertz, 70% duty cycle, and I've got on the yellow one. I've got a rise time less than 1 microsecond. But on the green one, which is after the op amps, I can see I've got a rise time of about 38 microseconds, which is probably what the data sheets for the chip would show, I'm expecting anyway from that chip. Now, for this application I'm doing, that's actually not good enough. And so what I've been doing is working out how to speed that up. In fact, I'll change the chip. But all in all, this thing's hasn't turned out to be too bad. I'm not sure whether this noise here is real or not, this digitizing noise across on the flats, the tops and the bottoms. What I will need to do is when I get home, I'll compare that against another scope and we'll be able to see how good this is. It is a bit unstable in the trigger in getting a stable signal. And what I actually found, the third-party person actually wrote another screen, complete package to talk to the same oscilloscope. And I actually can run that. And this one's a little easier to use because I actually can physically move things, rescale them. And this one, probably the triggers are more stable. The reason this thing's flashing like that is actually I've got both of these working together. Actually got two different display systems working, talking to the same oscilloscope simultaneously. And so I now jump between these two applications to pick the best out of both of them. This second one's also I can actually capture a screen or capture the trace and output it as a CSV file, which is I haven't used to date, but it sounds like it's quite good. So anyway, wasn't a long presentation. It was more just to actually confirm that, so that you can see what's happened here. This first one's gone unstable, mainly because the second one is running. I come back, it's now stable. So I just stop and start both applications. But for what I want, this has proved to me what I needed to know. I've rewritten the interrupt programs on this ESP application, and actually got it working as I want it to work. So I don't know if anybody's got any questions or not.
Yeah, I was wondering, Tony, is there something on that sort of scope you can do that you wouldn't be able to do on a normal scope?
No, actually, you can do the typical lizard view figures and do X versus Y as well as X versus time. I didn't. Well, the real advantage of this one is you can actually you can capture data and output it into a file. If you're really keen to look at exact timings.
Do you find it laggy at all? Does it take a long time to see measurement and actually seeing it, or is it instantaneous or instantaneous enough?
It's probably hard for me to tell because I've got a repetitive signal. I can't tell what the lag is anyway. What the delay would be. It certainly would have to have some delay because it's on a USB port.
I wonder how much does it take a lot of your CPU time? Does it drag your PC down, your laptop? Or is it just sort of providing a pretty good signal?
I'm running 50% CPU usage, and I've got a what is it, an i5 from about 4 or 5 years ago.
Yeah, it's quite a bit then, but not excessive, obviously.
No, I don't it's running. I mean, here I am running this and also running a Zoom call simultaneously. So
yeah, I think it'd be nice to be able to have your Pi program on one part of the screen and the oscilloscope on the other, and sort of quickly comparing what's going on.
But the other purpose of this, where I see the advantage is, if you're doing any mains work, you can put the oscilloscope straight on the device, as long as you don't plug the power supply in. Just run on batteries, and you can let the whole thing float above Earth. We used to use years and years ago. Used to use a little battery-powered Tektronix oscilloscope for just that purpose on variable speed drive, and that was magic in terms of you could just hook it on anywhere. Didn't need to worry about what the volts were, what the ground reference was.
Right.
And this strikes me as being equally useful for that application.
So it actually has batteries inside, or is it
Well, this is powered off the PC.
off the USB? Yeah.
So I just wrote, this is a laptop. Obviously, I didn't bring a desktop with me.
Yeah.
I did actually. I brought two with me. I was asked to not bring the third one with me. So
Nice.
yeah, yeah.
I think I bought the same oscilloscope, but like a more traditional looking one. Probably has the same innards.
Yeah, so this is a Handtech 6022.
Yeah.
But I just got it off Amazon here. Sort of, I did a bit of searching about, in terms of some, what people thought of it, and it was got a reasonable review, so grabbed it.
And the probes seem okay. Like everything that comes with it seems relatively well, good enough, I guess.
Yeah, no, it's served its purpose for me. I've been able to tune up the interrupts. I was having a bit of trouble with the interrupt wouldn't. It was taking too long to process, and I was missing, the timing was wrong. So I figured out what was going on, and which has been good.
There you go.
Yeah.
Any questions, anyone? If there's any in the chat. Yeah, there was a question like, how many bits does that operate on? Is that 8-bit machine, 8-bit oscilloscope, or is it 12 or 16, or what is it?
It's 8-bit.
8-bit.
Yeah, I was interested in the Batteryscope you had before. Was that a Tektronix or?
Yes, a little blue one.
Lovely.
Oh, they were magic. But that was in the days where like a 2-inch by 2-inch screen. It was hard to see, but the portability was fantastic.
Yeah,
Nice.
I've followed those. There are some really good projects like showing the design process. So via the techs, there are two main Tektronix sites. One of them is Tech Wiki, and I can't remember the name of the other one. Tech Museum, Tech History, something like that. And yeah, they've got the prototypes for one of the small scopes. It's really, really impressive, like just amazing to see. And then somebody's done a follow-up. What's the smallest oscilloscope they could make these days with is it OLED screen?
Yes.
I'll try and find some links and share them in the chat.
Just if it gets too small, it's kind of hard to see what you're doing. See what's telling me.
Well, that Handtech there being 8-bit, I was a bit frustrated with that. 8-bit, I'm used to such like excellent resolution on a good oscilloscope, but it's good enough, because if you're looking at the rise time, you don't need to worry about resolution beyond 8 bits.
Yeah, that's right.
But I was thinking that's where that noise is coming from on that on your flats. So I think that's just like the lowest significant bit is flapping in the breeze, as you see in Australia.
And so I'll be interested when I compare it against another oscilloscope I've got at home, and we'll actually see whether it's actually noise on the processor, or is it just this oscilloscope doing it. But for what I was doing, who cares? It served the purpose.
Cool.
I was trying to do something silly. I was trying to run an interrupt at 100,000 interrupts a second. So came to the sensors and reconfigured the code.
Any other questions, anyone? comments? Oh, good. Thanks a lot, Tony.
Yeah, no worries.
Very interesting to see that piece of kit. When I'm buying one, who knows? Thanks. So let's take a short break, and we'll come back. We'll have one more talk, and then we'll finish the night. So
Yeah, sorry, my internet's really choppy. I don't know if you guys can hear me. Okay?
yeah, can hear you.
Can you guys hear me all right?
Yeah. Do you have a question?
Yeah, I was just going to ask actually. Yeah, Tony, it's like, why are you doing 100,000 interrupts a second? What's why don't you just do it in a main loop?
What I was doing is I'm putting out a kilohertz square wave, but I wanted to have 1% variation, or a granularity. So that's why I ended up with 10 to the 5 interrupts. Now I've changed the way that works. I'm now to get where I want variable duty cycle. I'm now I just do an interrupt, then change the interrupt time, let it interrupt again, and just keep swapping backwards and forwards. So each time it interrupts, it changes the interrupt time. And so now it's only doing 1,000 interrupts a second, not 10 to the 5. But the main purpose of this was the downstream.
Okay, that makes a lot more sense because
Yeah, I was expecting too much of this little ESP to do that, and then do some other work as well. Because I'm right.
okay. I'm not sure what you're. Yeah, I'm not sure what your application is, but if if you're running that kind of high frequency of interrupts, it's probably better to just spin or wait for a certain number of nanoseconds or something like that in a main loop, because it's quite wasteful to have the interrupt, because it basically means that the processor has to store a lot of stuff on the stack, like what the current state is, and
all of that.
run your little interrupt and then restore the state, and then so you're basically getting that's quite wasteful of CPU resources.
Yeah. No, so what I normally do is I run a state machine. This is a machine controller, so I run a state machine that cycles every 10 milliseconds. But the interrupts we're trying to get this PWM to work.
My internet's really choppy, so I'm not sure if you've got that or not.
Why wouldn't you just use a timer attached to the pin if you want that sort of square wave?
No, I've got to have because I'm running a state machine where I'm doing different things at different times. I need something that will an interrupt-driven time base to make sure that some of these parts actually keep constant time or constant frequency. If I just put delays in, I'm going to end up with a waveform that changes frequency ever so slightly.
Yeah. It's a PWM wave that does something, but I'm not sure what the application is, so it's really hard to understand.
It's a electric vehicle charger.
Okay.
And you've got you tell the vehicle what the capacity of the supply is by the duty cycle of the PWM signal. So it's something like 0.6. Duty cycle by 0.6 is the current rating of the source.
Okay.
So a 50% duty cycle, etc. 50 by 0.6 is the number of amps it can draw.
Right. So does that mean you have to be really quick about responding to any change in
Yes.
reading?
So the reason the state machine is running around at 10 milliseconds, the absolute maximum time you can change state is sometimes 100 milliseconds.
Okay.
So you've got to have measured some analog voltages, made decisions, and then change state, and sometimes drop out contactors in under 100 milliseconds.
Yeah. So 100 milliseconds is what? That's 10 times a second, right? So
Yeah.
so 100,000 times a second seems way over the top, doesn't it? You know, I think you don't want anything to blow up and catch fire. It sounds like, you know, it's
I know it's the handshaking between the electric vehicle and the charge controller. They've got to work to the same standard, and they expect things to work at a certain speed or respond in a certain time. Timeliness.
Okay, so do you have to continue to handshake on every interrupt, or can you just like do the handshake initially and then you know, sort of do your protocol thing?
The handshaking between the vehicle and the charge controllers at 1 kilohertz. So it's relatively slow.
Okay.
But
Wow.
when you talk about dropping out, you know, you got to respond within 100 milliseconds. You'll have a contactor, say a 60 amp contactor would have a dropout time of say 20 or 30 milliseconds.
Mm-hmm.
So some of these are eat into that time base pretty quick.
Okay, I see your problem now. You want to respond quick to events and you know, to save a bit of power, you know, and optimize things as well.
Yeah, exactly.
Got it.
Tony, in the e-bike world, you can afford a much slower response to charging events. I'm curious then what the vehicle is that has a protocol that is as fast as that.
All electric vehicles that plug in with the charger on board, and you apply either 240 volts or 3-phase 415, follow this IEC protocol.
What was the name of the protocol again?
I think it's J1772, I think, from memory.
Yeah, there's a few different things. The same protocol is used for type 1 and type 2, and there's a ISO and there's an American standard, but they're all actually pretty much the same under the hood as to what they require. So, and it's not about sort of cutting power for the sake of saving power. It's for safety, because a lot of the time you want it, if it loses that modulation for a moment, then it indicates that the control pins have been disconnected between the charger and the car, and at that point the charge point has to immediately cut the power, so you don't get arcing across the pins between the charge socket and the connector.
So the control pins are the shortest, and they'll disconnect first, and then the active and neutral pins are slightly longer, and then the earth pins are the longest one. So the idea is you can actually get the power off before you start pulling the active and neutral pins, and you don't draw an arc that way. And equally, someone can't put their finger into the plug and socket and have a live device.
That's the same for USB, where there are a couple of pins shorter, USB-C and USB 2.1 and 3.x.
Mm-hmm.
Yep.
Yeah, 100 watts over those USB connectors, the USB-C connectors, is amazing, isn't it?
Yeah.
Those type 2 connectors can carry 43 kilowatts.
Yes, yeah.
A little bit more bulky.
Yeah, I read that they're expensive, so they're not rolling out as quickly as I think some of the people want to see.